11s. Today we'll be covering and introducing exercise 9A on sample spaces and probability on page 314 of your textbook. Now I understand it might seem a little bit going too quickly regarding content, but chapter 9 is probability. As exercise 9A is a lot of it's actually revision from stuff you've completed over or even in year 7. So some of it's stuff you guys already know, and hopefully you guys can apply that level of understanding in our exercise. A couple of definitions, just as a quick reminder of things that we need to cover. Sample space is the set of all possible outcomes, something that should be quite familiar with you. So for example, rolling a dice, or the sample space or the possible outcomes is 1, 2, 3, 4, 5, 6, and we represent the sample space using those squiggly line brackets you can see in this example right there, those squiggly brackets. An event is just a subset of the sample space. So for example, an event could be rolling a 4, which is a specific subset of rolling a dice. And complementary events, complementary meaning making up a certain space or a certain sample space, same as, for example, complementary angles makes a certain angle. So in our situation, we can actually apply that formula by saying the probability of everything is not A. That's what we use to symbolize not, the dash. So A dash, means probability of not A, is equal to 1 minus the probability of A. Now, speaking of probability, just a quick reminder that the probability of A, let's call A an event, let's say A is tomorrow raining. So the probability of tomorrow raining is, now actually that's a poor example, let's go with the dice actually. Let's say the probability of rolling a 5 is the number of outcomes in which you roll a 5 divided by the total number of outcomes, so the total number of times you roll the dice, for example. And so probability of A dash in that situation will be the probability of not rolling an A, and so probability of not rolling a 5. Probability of not rolling a 5 is equal to 1 minus the probability of rolling a 5. Now that's a lot of words, feels like a tongue twister, but let's jump straight into an example. A lot of the stuff, like I mentioned, is stuff you covered over last year, or before that, or it's common sense, and hopefully we can apply that here as well. So suppose that a card is drawn from a pack of 52 playing cards, something that you'll be very familiar with by the end of this topic, and that each card is an equal likelihood of being drawn. So we need to find the probability that the card is black. We're going to use our formula, so we're going to say the probability, let's write A down here so we know, probability of, and I typically like to write the terminology as probability of black like this, equals to, and we're going to use the number of outcomes in which the card is black. You might know that half the cards are black, half the cards are red. Hopefully you know that. Half being 26 out of a total of 52, which gives us, well, half. So the probability of getting a black card is half, and you'll notice it's actually going to be less than 1, because all probability together needs to add up to 1. The probability of a card being a king, once again, we write down probability of, or PR bracket, of king, is equal to, well, what's the probability of getting a king? We know that there are how many outcomes of kings? We know there's 4 kings, so I'm going to write 4 out of the total of 52. Once again, we're going to go ahead and simplify that. How many times is 4 going to 52? We know that's 13, so it's 1 out of 13. The probability of getting a king is 1 out of 13. Next example. The card is drawn at random from a pack of 52 cards. What is the probability that the card is not a heart? So like I mentioned earlier, not, we use the dash to symbolize it being a complementary event. So I'm going to go ahead and write the probability of, now you can draw a heart if you want to, you can write the word heart, that's up to you. So the probability of not heart is actually going to be symbolized by, well, how many not hearts do we have? So we can say, well, not hearts, we have clubs, spades, and diamonds, which make up 3/4 of a deck. So I can write 3/4. You could have done it the other way around by saying probability of not heart, that's a terrible heart, but it'll do. We're going to use a formula over here, 1 minus the probability of a heart. So that's 1 minus, well, we know a heart is a quarter, so that gives me 3/4. Now the same thing, I'm going to apply that principle in our option for B. So we're trying to find the probability of a card being not an ace. I'm going to say the probability of, and I'm going to try my best to draw an ace. Actually, that's not even a thing. I'm just going to write ace. Probability of ace dash equals to 1 minus the probability of an ace. Now we know aces is 1 in 13 cards, right? There's 1 in 13 cards, or we can write it as 4 out of the 52. If you need to Google how many cards are in a set of cards, you may need to do that, and just make sure you've got that in your resource book, because that's a very common question. That ultimately simplifies to give us 12 out of 13, which is a probability of not getting an ace. Quite likely. And finally, we're looking at the example of a random experiment, and this is one where we have to apply our understanding of algebra. So for this one over here, a random experiment may result in outcomes of A, B, C, D, or E, where A, B, C, D are equally likely and E is twice as likely as A. From here, like I mentioned earlier, it's just an application of what we already know. So for example, let's go ahead and define each probability. Let's say A, B, C, D are all the same, so let's call them all probability being x. Now remember that every single value of x needs to be less than 1, because in total they should add up to 1. Now obviously E being twice as likely as A, or twice as likely as B, and twice as likely as C and D, you get the point, needs to be, well, 2x. So E is ending up as 2x. So we've already defined it, the probability of E. Now we've got the different probabilities, but they don't give us a certain number. Now I mentioned earlier, you might notice that we have to have the probabilities adding up to 1. So theoretically, x plus x plus x plus x, so that's from this section here. Now we need to also add this section here, because that's involved as well, plus 2x, equals to 1. I can simplify the right hand side and end up with 6x equals to 1, which ultimately ends up with x equals to 1 over 6. And if x equals to 1 over 6, I know that I have the probability of x, well not x, sorry, my apologies, probability of any A, B, C, or D being 1 over 6. But given that we know the probability of E is 2 over 6, we know that equals to 1 over 3, or before simplification, 2 over 6, and therefore 1 over 3. For B, pretty straightforward, applying our understanding of that probability of not B, we know that equals to the 1 minus the probability of B, which gives me 1 minus. Now, probability of B, remember, is the same as A, C, and D, which is going to be x, or in other words, 1 over 6, which therefore gives me an answer of 5 over 6 for the probability of not B. Hopefully that makes sense, and a lot of it is pretty easy to pick up. Apologies if I went through it too quickly. Best of luck, and if I don't hear from you again, enjoy your holidays.